Hi guys, in this tutorial I'm going to solve question number 8, Mechanics 1, November 2021. This question related with vectors. In this question, I and J are horizontal unit vectors directed to the east and to the north. At 7 a.m., we start 7 a.m. Ship leaves a port and moves with constant velocity. The position vector of the port is, this is the initial position, R0, initial position is negative 2i and 9j. At 7:36 a.m., the ship is at a point final position. This is the first final position. It's better to show that in XY plane. The ship started from initial position at 7, which is -2 and 9. Let's say at this position, at -2 and 9, -2 I and 9j. Then at 7:36 a.m., the ship at a point 4 and 6. Now move 4 and 6. Let's say this is the position final. The path of the ship from this position to this position. Show that the velocity of the ship is 10i and -5j. To get velocity, V equals, you can start with the final position is equal to the initial position plus Vt. So the final position given, which is 4i and 6j, 4i and 6j, 4i plus 6j is equal to the initial position, which is -2i plus 9j, plus v times t. T is from 7 to 7:36, so the time is equal to 36, but this is minute. To convert from minute to hour, 36 divided by 60 simplified, you will get a 3/5. 3/5 hour, or you can write it 0.6 hour. So now 0.6 hour, you can calculate the value of V, move to the other side, 4i plus 2i, 6i, 6j minus 9j is -3j, is equal to 0.6 times V divided by 0.6. So V equal 6 divided by 0.6i and -3/0.6j. So you can find velocity, which is 6 divided by 0.6. So the answer will be 10i minus 3 divided by 0.6. So the answer will be 5j. This is part A. He asked you to show that the velocity will be 10i minus 5j. So now if we start to change the position, now we'll start again. We consider this value initial one, and the direction of the velocity is 10i minus 5j. In part B, find the position vector of the ship T after leaving the port. In general, to get the position vector, R is equal to R0 plus V times T. So R is equal to, the port means the initial position. It's written here, the position vector port is. So minus 2I and 9J plus the velocity, which is 10I minus 5J multiplied by T. This is the final position. You can get in direction of I component and in direction of J component, but in terms of T, minus 2I and 10I times T, so negative 2 plus 10T, and for J is 9 minus 5 times T. This is part B, find the position vector of the ship T hours after leaving the port. Third part, at 8:48, a passenger on the ship notes that the lighthouse is due east of the ship. So direction of the velocity, when it is moving in this direction, it's a negative 10. Let's say this is the direction of the ship, which is now 10I and minus 5J. At 8:48 a.m., so you can find the time. You can start from initial position, but the time will be 1 hour and 48 minutes, or you can start from this position 7:36 to 8:48, both correct. When he noticed that the lighthouse is due east, means if say this is the original point, will be in this direction. Let me shift this part down to explain. So this means the ship will be at this point because it's written, notes that the lighthouse is due east, will be like this. Let's say the lighthouse is in this direction. Then at 9 a.m., the same passenger noticed that the lighthouse is now northeast of the ship. So when it is continuous, so at 9 due north means will be like this. Now the ship at this point, but it will be north. But at 8:48, it's written will be east north here. At 9 a.m., same passenger noted that the lighthouse is now northeast. Sorry, I will show that will be here. Northeast means will be exactly in this direction. This is at 9. And this is at 4:48, 8:48, and This is at 7:36. 7:36. And I will show direction of this part, which is just this point, to be like this. At 7. At 7, then at 7:36, then at 8:48, then at 9 at this position. Let's now read part C. Find the position vector of the lighthouse. The position vector of the lighthouse when the ship moves at this point. So the final R is equal to R plus VT. The final position R, the initial one, if we start from 7 again, so the initial position, it was -2 and 9, I think, -2 and 9. -2 and 9, correct? -2 and 9. -2 and 9, -2i and 9j, plus velocity, it's 10i minus 5j, 10i minus 5j, multiplied by the time. So from 7 to 8:48 will be 1 hour and 48 minutes. So 1 and 48, we can convert it to be in hour. So will be 9/5. So the time is 9/5. Simplify to get the final position, -2i plus 9j, plus when you expand, you will get 18i and 9j. Simplify, -2i and 18 is 16i. So the final position for the ship, find the position vector. In part, find the position vector of the lighthouse. The position vector of the lighthouse now will be in this direction. This part will be 16i. So the lighthouse will be now is k multiplied by k in direction of I, because now will be to the east. This is the position of the ship, will be 16i. This is the position. But now when it's at 8, at this point, this will be 45 degrees exactly. If this is 45 degrees, so the ratio between X and Y will be 1. So in part B, in part C, he asked to get the position vector of the lighthouse. The position vector of the lighthouse have to be in the same direction of I. You can calculate it mentally, because now it's 16. I will find the position vector first at 9 for the ship. So R is equal to, same, we already have it in terms of I and T, this part, -2i, -2i plus 9j plus times T, the velocity 10 and minus 5, 10i and minus 5j, but the time now will be 9 from 7 to be 2 hours. So the position vector will be -2i plus 9j plus 20i minus 10j. So the position vector of the ship at 9 will be -2 and 20 will be 18i minus 1j. So now 18, this position is 18i minus 1j. So by comparing between this part, this length is 1, and we move from 16 to will be 18. Now to move it to 18, this means we move 2. By the same way, this part is 2, but this is 1. So this will be 1, this will be 1. So shifted from 18 to add 1 will be 19. So L, the position vector for L is equal to 18i, and 1 more will be 19i. Again, when we move to this position, we move 2 to the right and 1 unit down. Because this angle is 45 degrees, so the ratio between x and y is same, 1 to 1. So if we move down 1, this means also we'll move to the right 1. So we'll shift it from 18i to 19i. If you get the position vector for between L and R and compare the same ratio 1 to 1, you will get the same answer. In part D, find the position vector of the ship when it is due south of the lighthouse. To be south of the lighthouse, again, when it's moving from this position to be here, so again, we'll find the final position, which is negative 2i plus 9j plus v, which is 10i and minus 5j multiplied by t. So you can find your answer in terms of t. It's found before, negative 2 plus 10t in direction of I, and 9 minus 5t in direction of j. When the ship is south of L, this means the x coordinates will be same. And we already have x coordinates here is 9. So by using x equating with 19, so negative 2 plus 10i, 10t is equal to 19. So 10t is equal to 21. So t is equal to 2.1. He asked to get the final position now when t is equal to 2.1. So substitute by the value to be 2.1 in both. So without more calculation, it's clear that you will find this value is 19i plus 9 minus 5 times 2.1. This is direction of j. So r is equal 19i plus 9 minus 2, 9 minus 2.1 times 5. So negative 1.5, negative 1.5 in terms of j. That's it. And this is the final answer in part. Thank you.